interpreting rate of change and slope. This is lesson 5.3 from your text. Your EQ, how can you relate rate of change and slope in linear relationships? We have 4 I can statements that are covered in this lesson. I can show that a function is linear by identifying constant change in x and y. I can find the average rate of change given ordered pairs, a table, or a graph. I can interpret the average rate of change for a real-world situation. I can describe a function as increasing or decreasing based on a graph or a table. So this first slide here, this is our vocabulary. Let's take a look at what's in this white box here. It's labeled slope because these all mean slope. There's lots of ways of representing slope. Slope is rate of change, okay? It is represented by this lowercase m. It is represented by rise over run. It is represented by the change in y over the change in x, which is just a short way of writing y2 minus y1 over x2 minus x1, okay? This is delta notation. I like delta notation because it takes even less writing than this right here, okay? That is the Greek letter, delta, change in, and it tells you that right here. And also because we're working with functions, you can replace y with f of x. So you could write y2 as coordinate, the y coordinate of a point, or y1 is the y coordinate of a different point. That's also the same thing as f of x of 2. F of y, f of x of 1. Okay, sorry, it's lots of variables and symbols, right? It's a mouthful. Rate of change, that is slope. It is a ratio that compares the change in y to the change in x, okay? Change in y, change in x. Rise, so if you're visually looking at a graph, any 2 points on that line, you can find the slope by counting rise and run. So starting at, you know, if you have 2 points and one is lower than the other one, how many units do you rise up to be level with this one, and then how many do you run over to get to it? That's slope, rise over run. So rise is the difference in the y values. You don't have to have a picture. You can just have 2 ordered pairs and you can subtract the y values like it shows you right here, y2 minus y1. Run is the difference in the x values. You can visually count that on a graph, or if you're just given 2 ordered pairs, either in like ordered pair notation in parentheses, or even in a table, you can find the slope that way. Find the run of that is just x2 minus x1. You subtract the 2 x values. And so the slope is the ratio of rise to run for any 2 points on the line. This is your slope formula. Should look familiar. Slope of a line, lowercase m, given 2 points. Any 2 points of the line. You can take any 2 you want. x1, y1, x2, y2. All right? To get rise over run, if you're just given the 2 ordered pairs, well, you're going to subtract the y values in the numerator and subtract the x values in the denominator. And then once you simplify this, you'll have a ratio. You'll have a fraction, or it might simplify down to a different, like a real number. It could be positive, it could be negative, it could be 0, it could be undefined as long as it's not a function. Okay, remember, if you have a horizontal line, that has a slope of 0. A vertical line has undefined slope. If you end up with a positive number as m as your slope, you have a positive slope. If you end up with a negative number, you have a negative slope. And so you can see there's an example worked out here. There's 2 ordered pairs that are given. That's all you need to find the slope of a line that passes through 2 points. You just need the 2 ordered pairs. You pick one of the ordered pairs to be the first one, x1, y1. Pick one to be the second one, x2, y2. And then just use the formula. So m equals y2 minus y1 So that's negative 11 minus positive 8 over x2 minus x1. Positive 2 minus negative 3. So in the numerator, negative 11 minus 8, you're adding two integers that are both negative. You can think of it that way. It's negative 11 plus negative 8. You get negative 19. 2 minus negative 3. When you have a subtraction sign and a negative sign next to each other, like we have here, you add the opposite. So this becomes 2 plus positive 3, becomes 5. So this value right here, even though it's an improper fraction, it's okay for slope because remember, slope is a ratio. So ratios look like fractions, but we don't have to simplify it to a mixed number or a decimal. We can leave it just like this because it's slope. It is a ratio. Ratios, you were comparing two things, rise to run, negative 19 to 5. So if you rise 19 units and then you run 5 in the negative direction, the line that you get would be the line that passes through these 2 points. In this slide here, you're going to watch a video. There's lots of videos in this lesson, okay? They're all on Khan Academy. They're going to take you right to where it's going to show the video. In this slide, you're given 2 points, negative 9, 6, and negative 6, negative 9. And I want you to use the slope formula to figure out what is the slope of the line that passes through those 2 points. Slide 6 is a video. Slide 7 is a video. Slide 8. You did something like this in Delta Math, where we have a table of values, and we got to figure out what's missing. And the trick here is that you want to identify what's missing so that the table represents a linear equation. You got to find the pattern. What is happening? And keep the pattern going. Okay, so you just look on the y side for the pattern and then complete the pattern by filling in what would come next. Okay, slide 9, this is a video. Slide 10 is a video. Slide 11, over which interval, okay, so you have 4 intervals here. Your choices are A, B, C, and D. You have 4 intervals. Shows a average positive rate of change. So this blue line is not linear. It's kind of squiggly, but it is a function, okay? It passes the vertical line test. Never does an x value repeat with different y values, okay? If I was to hold a pencil up to my screen and like move it across, it would never touch the graph but more than one time in any one spot. So that is a function, but it is not a linear function. And looking at these intervals, notice this isn't x and y, we have t and g of t. So they're labeled differently, and that's okay. So the function is g, t is the variable that's on our typical x-axis. It could be time. And so time doesn't make a lot of sense in the negative, so maybe it's not time. But you're going to look to see which of these intervals show positive rate of change, and that's going to make a lot more sense once you actually do the video before it. Describing functions. This is a chart for you with a piecewise function. So over here, this is a function with different pieces that have different properties. So section A, piece B, piece C, D, E, and F are all defined over here in ways that you can describe functions. So for piece A, it has positive slope. It is going uphill to the right. So we say it slowly increases at a constant rate. It's increasing. Positive slope means it's increasing. Constant rate means that the line is straight. Okay, the rate is staying consistent. It's being constant. B is also positive, but it is much more steep, so this is quickly increasing at a constant rate. C is going downhill. D is also going downhill. Both of those are straight line segments, So C is slowly decreasing at a constant rate, where D is quickly decreasing at a constant rate because the slope is much more steep. For E, this is not a straight line segment, it's a curve. E is increasing because it is starting low and ending up higher. And the rate is not constant, it is an increasing rate. So it is speeding up. F is a flat line segment, it's horizontal. If you have a horizontal line, the slope is 0. So there is no change happening here. It is just staying the same. It is constant, constantly the same with no change because it's straight, but it's staying the same. It's not changing. And then the last one is the shown function. Okay, the function on this picture here, is it increasing or decreasing? That's a multiple choice. So you probably want to come back and start with slide 4, watching that video first. I'm going to put you into student paste, and you're going to have some time to work on this, and then we'll come back and we'll review your answers. So you have until 2:25. Okay, at this point, everyone should be in the Pear Deck. Okay, so it is 2:25. So what we're going to do now is go over the correct answers, share some of your answers. I'm going to turn off student pace for a minute, and I'm going to have everyone come back to the Google Meet tab. So if you are in the Pear Deck tab right now, just leave it, but come back to the tab with our Google Meet, because I'm going to be going over all the correct answers, showing some of your work, and explaining how you do some of this stuff. So for slide 5, where you had to use the slope formula, the correct answer was -5, okay? And quite a few of you figured that out, so I'm pretty proud of this class. That's really, really good. I do want to show you how it's done, though. So I'm going to open up the Jamboard that I put a link to in our Google Meet. You don't have to go to the Jamboard, but you can look at it later if you wanted to. But I'm going to share it with you through Google Meet, so it's being presented to you. The 2 points that are given, -9, 6, and -6, -9, we're going to use those and the slope formula to find the slope of the line that passes through them. So slope is change in y over the change in x. And what you can do is decide, which ordered pair is going to be your first ordered pair. So I'm going to make this one my first ordered pair, and then I'm going to make this one my second ordered pair. You can color code or you can label. It's up to you. This is going to be x1. This is going to be y1. Colors help. This is x2, or this is y2. And so what I'm going to do is subtract. Oh, it's a little weird. I'm going to subtract, and it helps to write in the subtraction symbols before you start plugging in numbers, because it's really easy to forget about a negative or a subtraction sign. So I like to write them in first. In the numerator, I'm going to subtract my y values. Now, the order that I choose to subtract them doesn't matter. Okay, I could put the 6 first, or I could put the -9 first. It really doesn't matter. So maybe I'm going to put the, since I already grabbed red, let's go ahead and put -9 first, and then I'm going to put 6 second. Now, because I've put -9 first, I have to use x2 in the first location in the denominator. So x2, the change in x, it's going to be, now I guys keep the ordered pair together, all right? So -9, -6, I got to keep that together. So it's -6 here. And then switching back. Okay, so my 6 I need to keep with -9, and then that's going to go right below it. So notice how the ordered pairs, they're stacked with its little buddy. And now we just have to simplify it, okay? So when you are, I've never used this before. How does this work? This is a laser pointer and like fades away. Oh, that's interesting. So right here, when you have the minus, yeah, that doesn't work too well with like the delay. I don't really like that. Okay. minus a negative becomes plus a positive. Remember that? So if you ever have subtraction of a negative, you instead add the opposite. And then to simplify this, in my numerator, negative 9 minus 6 is the same as negative 9 plus negative 6, which is negative 15. In the denominator, negative 6 plus positive 9 is going to be positive 3. And I have to simplify this a little bit to get one of those 4 choices. Okay, so negative 15 and positive 3. Well, I know 3 goes into 15 5 times evenly, so this is actually negative 5. So that's how we get the answer for that problem that we were just looking at on slide 5. The correct answer is negative 5. That's the one that's equivalent to the slope that I got. See, the next interactive one is slide 8. Identify the missing value. Okay, so if you look at the pattern, the y's are going from 5 to 7 to 9. What comes next? 11. 11 comes next. So a lot of you got that correct. Slide 11, average rate of change. Which interval is the correct interval? So you kind of want to look at the blue line for this. Negative 3 to 0, where t is greater than or equal to negative 3, or you can read this as negative 3 is less than or equal to t is less than or equal to 0. So on the t-axis, negative 3 is here and 0 is here. So what's the blue line doing from negative 3 to 0? Well, it starts here and it goes down. That's not positive rate of change. Negative 7 to negative 4. Starting at negative 7 to negative 4, look at the blue line, and it's going down. That is not a positive rate of change. We're looking for the average rate of change to be positive. So far we've seen just negative. Negative 9 is less than or equal to t is less than or equal to negative 5. Negative 9, negative 5, right here. We're going down, we're going up, but then we end up coming down. So that's still negative. And the last one must be it. That's our last choice. 4 is less than or equal to t is less than or equal to 8. 4 to 8. 4. We're here. We're going down, but then we're going up, 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 and we end up much higher than we started. So the average rate of change is positive here. So D is the correct answer. You should have D. And quite a few of you, 2 of you, quite a few, to figure that out. All right, and then the last one you had to do, slide 13, is the shown function increasing or decreasing. Okay, so think about slope. This line would have negative slope because as you go from left to right, you're going downhill. Negative slope and a decreasing function are one and the same, so it's decreasing, decreasing. So what I'm going to do for you now is turn it back to student paced. And then that way you can go back through. If you didn't get to watch all the videos yet, you can go back. You can change your answers to match the correct answers. You can start taking notes on this. All right. You can go to any slide you want to at any time.